In this module of 9.6 of Chapter 9, I will cover stage structure and stage frequency analysis using the multi-stage life table model approach. Stage frequency analysis is the average time required for arthropods and other cold-blooded organisms to attain various stages in their development and their survival to those stages. This analysis has received considerable attention because of its importance in applied ecology. The definitive method for determining individual level development and survival rates is to monitor survival and developmental rates of newborn individuals maintained in solitary confinement. However, for logistical reasons or because some species subgroups cannot be maintained in solitary confinement, this approach may not be possible. Data collection thus necessarily involves information on the development and survival outcomes of individuals maintained in groups. For example, suppose 100 newly laid spider mite eggs are placed in solitary confinement on a single leaf disc in a petri dish lined with saturated cotton to keep the disc fresh. Each day, the number in each stage, i.e. egg, immature, or adult, is counted until all individuals have either completed development or died. On any given sampling date, more than one of the stages is usually present, because there is variation in the developmental rates for each stage. The objective is to determine the average duration of each of the first two stages. There are three ways for an individual to exit an age class, including surviving to the next age within a stage, surviving to the next age and into the next stage, or by dying. Thus, each individual is subject to two competing transition risks, including the force of mortality and the force of stage transition. A schematic of this problem of estimating stage duration in the spider mite is shown here. We have the egg stage, which lasts up to 5 days. These hatch and thus transition at different times to the immature stage, which in turn transitions to adults, again at different times. Thus, we need to estimate two categories of transitions: the age transitions within a stage and the age stage transition between stages. Here is a graphical description of the stage frequency data for spider mites showing the age on the lower diagonal and the bar graph groupings of eggs, immatures, and adults distributed across these ages. Note that there are only 3 days in which a single stage, that is, the immature stage, was present. Note also that of the 100 eggs that initiated the cohort, a total of 52 survived to adulthood. The multi-state life table model can be formalized as follows, where I equal the stage, X equal age, N equal number, and P equal the probability. Scripting is shown as follows, with the general expression given to the left and an example given to the right. I will give only the examples in words. The first example denotes number of individuals in stage 2 at age 4. The second example denotes the probability an individual in stage 2 at age 4 survives to age 5 within stage 2. The third example denotes the joint probability of surviving from age 3 to age 4 and transitioning from stage 1 to stage 2. The multi-stage life table model is given in this expression, in which the number in stage I at age x plus 1 equals the sum of the two expressions to the right. This table contains the specific data, which we divide into two subtables. In the leftmost subtable, we have age in the first column, and in the next 3 columns, we have number alive at stage, including the age stage. Note that at age 5, there are 0 eggs remaining. Next column contains the numbers in the immature stage at different ages. Note here that there are no more remaining in this stage by age 12. That is to say, all have matured into adults. Note that we have our 52 adults that survived from the newly egg stage. In this rightmost subtable, there is time in column 5, which corresponds to the age in column 1. In this next column, we have surviving and unhatched eggs, and in the last column, we have surviving pre-adults. Note at the bottom with the sum of the survival schedule of the eggs yields the average egg duration of 3.37 days. We sum the entire survival schedule to yield the egg to adult duration of 7.85 days. By subtracting the latter number by the former number yields the immature duration of 4.48 days. Therefore, this multi-stage life table model is useful for estimating the stage durations in species such as the spider mite with overlapping stages due to different developmental rates within a stage when individuals are maintained in groups. This ends Module 9.6 in this 9th chapter.